In this video, we're going to explore the sine and cosine values in the first quadrant of the unit circle. And we're going to do this both in degrees and in radians. We're going to start off with degrees because there's a connection to our special triangles that we've looked at in the past. So we're going to start off with the most basic one, which in my opinion is the 30, 60, 90 triangle. Draw a nice little 30, 60, 90 triangle. All right, so we've got a 30-degree angle here and a 60-degree angle here. Now, there's a reason we call it the unit circle, because the radius is 1 unit. And you can hopefully tell by this picture, we go from here to here, that's 1, here to here, it's 1, and so on. If you think back to your geometry class and when you talked about 30, 60, 90 triangles, there was a ratio of the sides here, that the side across from the 30 was considered x, across from the 60 was considered x root 3, and across from 90, which is the hypotenuse, was considered 2x. What we can do, if we're looking for a radius to actually be 1, is I can find out the value of x that makes that true. So I could take my hypotenuse, which is supposed to be 1, but it's also 2x, and find out that x is equal to 1/2. So our hypotenuse then becomes 1. Our side here becomes 1/2 of the square root of 3. I'm going to write that as the square root of 3 over 2. And then the side across from the 30 is 1/2, because that's what x actually equals. So at this point we have the sides of the triangle, if this is a 30, 60, 90 triangle, with a hypotenuse of 1. But what we're interested in finding are the sine and the cosine values. Now the cosine value, if you think again back to your geometry class, you probably learned this little phrase here, SOHCAHTOA, which means the sine is the opposite over hypotenuse. The cosine is the adjacent over hypotenuse. And we'll talk about tangent later, but it would be the opposite side over the adjacent. So if I'm looking at my 30-degree angle, my cosine would be the one that's not across from the angle. So that would be my square root of 3 over 2, and I would divide that by 1 to give me the square root of 3 over 2. So the cosine of 30 degrees would equal the square root of 3 over 2. The sine of 30 degrees would be the opposite side, which is 1/2 over 1, so it would be 1/2. Now I can do the same thing with this triangle, but transposing it. So instead of making a 30, 60, 90, I'm going to change that angle a little bit, make it a little bit steeper, which changes some measurements around a little bit. So now I've got a 60, 30, 90 triangle. Same ratios I had before. We said the one across from the 30 was 1/2. The one across from the 60 was root 3 over 2. And the hypotenuse was just 1. So when I'm looking at the cosine and the sine of 60 degrees, what ends up happening is these just kind of flip-flop. So the cosine of 60 degrees becomes 1/2. The sine of 60 degrees becomes root 3 over 2. So the sine and cosine are flipping because the angle is switching around a little bit. So what happens though, we've got one other special angle that we want to talk about, which is the 45, 45, 90. And I'm just going to not draw that in because it's already drawn in. So there's a 45, 45, 90. So in this one we've got x, x, and x square root of 2. So what I'm looking for in this one is, again, the hypotenuse should equal 1. So I've got x square root of 2 is equal to 1. And that's my hypotenuse, and I want to find out what x equals, so I could find out these pieces here. So to do that, I've got a couple options. I think probably the easiest option would be to divide both sides by the square root of 2, giving me x equals 1 over the square root of 2. And I can then rationalize that, multiplying square root of 2 over square root of 2. gives me x equals root 2 over 2. And so that's going to be my 45-degree angle. So I can write that down. I'm going to look at x being square root of 2 over 2. And we already know that hypotenuse is going to turn into 1 because that's the radius of the circle. So there I'm going to write down the cosine and the sine of 45 degrees, which will be the square root of 2 over 2 divided by 1, so it's the square root of 2 over 2. And the sine of 45 degrees ends up being the same thing. So I've got all my measurements here now in degrees. The other thing I want to look at is we've got a couple other spots here, right here and right here. Now here's the cool part about the unit circle. The x-coordinate is going to be our cosine value. The y-coordinate is going to be our sine value. So if I look at this ordered pair right here, that ordered pair is 1, 0. This ordered pair here is 0, 1. Kind of the same thing, but flip-flopped a little bit. So what that tells me here, that 1 is the cosine. The 0 is the sine. And same thing here. Here I've got the cosine is 0, and the sine is 1. But the question is, what is that angle? Well, if I look at a circle, all the way around the circle is 360 degrees. If I didn't move anywhere, so remember this is a 45-degree angle, this was a 30-degree angle. If I didn't really move at all, if I'm just going in the x direction, my angle here is actually 0. So the cosine of 0 equals 1. The sine of 0 is 1. If I look at this point right here, I've gone about 1/4 of the way around the circle. So again, the whole thing is 360 degrees, and 1/4 of the way would be 90 degrees. So the cosine is 90 degrees, and the sine of 90 degrees. The cosine 90 is 0, the sine of 90 is equal to 1. Now, that's great. We've got all our degree measures. We are going to also look at a method of measurement called radians. And radians are kind of similar to degrees in that they're always the same number of radians around a circle, but it's not 360 degrees. What we actually have is something called, well, it's not called, but it is 2 pi. And think back to circumference of a circle. The formula there is 2 pi r. If the radius is 1, the circumference of that circle is 2 pi. So now we want to figure out how do we convert between the two things. So essentially we want a conversion 2 pi to be equal to 360. So 1 pi radians is equivalent to 180 degrees. So there's a conversion factor we can use. And our conversion factor is take your degree times pi over 180. And that'll tell us what our measure is in terms of radians. So if I look at 30 degrees, 30 times pi over 180, I can reduce. I can take a 30 out of each of those, and it gives me pi over 6. So when I'm looking at those measurements in radians, which is what we're really kind of working towards, the cosine of pi over 6 is root 3 over 2. And the sine of pi over 6 is 1/2. If I change that angle to 60 degrees, it's going to obviously change our radian measures. Let me go to my pen. 60 degrees, pi over 180. Well, there I can take out my 60 from both of those pieces. So I can make that a 1, and that becomes a 3. So the cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. And I can do the same thing with my 45-degree angle. So change that 60 to a 45. and cancel those out. And 45 taken out of 180 would give me a 4. And so that becomes pi over 4. So we've got the cosine of pi over 4 is root 2 over 2. And the sine of pi over 4 is root 2 over 2 as well. So again, these are the radian values that we're looking for. Now here's a cool conversion, easy one. When we're looking at this angle right here, if I take 0 times pi over 180, it still gives me 0. So it's still the cosine of 0 equals 1. And the sine of 0 equals 0. Ooh, said 1. With 90 degrees, if we go back to our conversion here, this one's actually going to be a little bit easier to work with than the previous ones. 90 degrees times pi over 180, you can take a 90 out of both of those, which would give me a 1 and a 2, and so that would be pi over 2. So I can say the cosine of pi over 2 equals 0, and the sine of pi over 2 equals 1. And these values are always going to be the same. They're ones you effectively want to memorize at some point. Again, the video is all about conceptual understanding, but at some point you want to memorize these values and know them pretty quickly. What we're going to look at in the next video is taking these measurements and moving them into quadrant 2 and quadrant 3 and quadrant 4 and see what happens when we do that.